Now, up till now, we've studied about the properties of metals, we've studied why metals and non-metals react to form compounds. In this chapter, we're going to study how metals are extracted from the Earth's crust. So, inside the Earth's crust, there are special substances called metal ores, which contain different compounds like metal oxides, metal carbonates, and metal sulfates. Metals are obtained from these ores, these substances found in the Earth's crust. In this chapter, we're going to study how metals are obtained from their metal ores, or how they're obtained from different compounds found in the Earth's crust. For example, some metals are obtained by heating different substances found in the Earth's crust. Some other metals are obtained by treating the substances found in the Earth's crust with chemicals. Still, some other metals are found by passing electricity through the metal ores or the different substances found inside the Earth's crust. So, which metals are extracted by which method from which substances found in the Earth's crust? That is what we are going to study in this chapter. The occurrence of metals. First of all, before we study anything in this chapter, we need to understand what the term ore means. An ore is a compound that is naturally found in the Earth's crust and contains the metal we want to extract. Ores can be oxides, sulfides, carbonates, and many other compounds. So, did you understand what a metal ore is? Basically, we have many substances inside the Earth's crust from which metals are obtained. For example, zinc is obtained from zinc sulfide that is found in the Earth's crust. Iron is obtained from iron oxide that is found in the Earth's crust. So all these substances which are impure and which are in the Earth's crust are called ores of metals. Okay, metals are obtained from these ores. Let's look at some common ores of metals. Hematite is the common ore of iron. So hematite is basically iron oxide, but it also contains rocks, sand particles, dust particles, and many other impurities. Hematite, here's a picture. Cinnabar is the ore of mercury. So basically cinnabar is a mineral found in the Earth's crust, and here's how it looks like. You can see this picture here, reddish in color. Copper glance is the ore of copper. Again, this is a picture of copper glance. So these are the special names given to the ores from which metals are extracted. Here, this is a picture. Calamine is the ore of zinc. Here, you can see this bright blue picture of zinc carbonate or calamine. Calamine is basically zinc carbonate, but it also contains a lot of other impurities. We don't say that mercury is extracted from mercury sulfide or iron is extracted from iron oxide. Why? Because the ores are not pure. Like, they contain a lot of dust particles, a lot of rock particles, and sometimes they even contain some other minerals. There's an ore of zinc, it contains both zinc sulfide and lead sulfide. So some ores contain many compounds also. So that's why we don't use the chemical name for the ore like zinc sulfide or iron oxide or mercury sulfide. We say cinnabar, hematite, or calamine. You must remember the names of these ores. So what's the basic process of extracting a metal from its ore? The first step in extracting the metal from its ore is the concentration of the ore. Concentration of the ore basically refers to purifying the ore. The ore has, say, silt particles, dust particles, rock particles, mud. So removing all these and extracting only the chemical is called the concentration of the ore. It's basically purifying the ore and cleaning it. The second step involves conversion of the ore to the relevant metal. That's the second step. We use a certain chemical process to convert the ore to a metal. The third step is the refining of the metal. You see, many times the metal obtained after the chemical process is very impure. Like, it also contains a lot of dust particles and it contains some small compounds attached to it. So we carry out a process called refining. As you can see, concentration of the ore involves removing sand, rock, and dust particles from the ore. These sand, rock, and dust particles are often called gangue. Understood? This is again an important term. The conversion of the ore to metal depends on the ore and the metal. Different ores, are treated differently to get the metal. Refining of the metal is generally conducted using a process called electrolytic refining, in which electric current is passed through the metal. We're going to study about this later in this chapter. Now you'll study about the concentration of the ore in higher classes. For now we will focus on these two processes: conversion of the ore to the metal and refining of the metal. We'll not study concentration of the ore just yet. Understood? So let's begin. Let's understand how different ores are converted to metals. Now the conversion of ores to metals depends on how reactive the metals are and what their position in the reactivity series is. Take a look at these metals: potassium, sodium, calcium, magnesium, aluminium. They're all very reactive metals. In our previous chapters we studied that potassium, sodium react vigorously with water. They explode with acids. Even magnesium and aluminium are very reactive with air, with steam. These metals are generally found in the form of chlorides and oxides. So the ores of these reactive metals are chlorides and oxides. Sodium, for example, is extracted from sodium chloride, common salt. Aluminium is extracted from aluminium oxide. Zinc, iron and lead are said to be moderately reactive. They are extracted from their sulfides, carbonates and oxides. Similarly, copper and mercury are very less reactive. They are extracted from their sulfides. Gold, silver, platinum are not reactive at all. They don't form any compounds, most of the time. So they are extracted in their pure state. What this means is that gold, silver and platinum don't have any ores. They're just extracted in combination with rock and other minerals and sand and mud and dust particles, but they're not extracted from, say, silver sulfide or say gold chloride. No. They are extracted in their pure state. Like they are found in an uncombined form inside the Earth's crust. So again, I'll repeat it for you. Very reactive metals are extracted from their chlorides and oxides. Slightly less reactive metals from sulfides, carbonates and oxides. Very less reactive metals from sulfides. And gold, silver, platinum, you can call them noble metals. They are extracted in their pure state. So you must have a rough idea of this, what compounds are the ores of which metals. But even if you don't remember them right now, it's okay, because you'll gradually remember all these things as we move along this chapter. First of all, let's study how metals that are low in the activity series are extracted. Metals that are low in the reactivity series are gold, platinum and silver. All these metals are found in their pure state.